Law of sines. You can see the law of sines here below. Sine A over A equals sine B over B equals the sine of C over C. Before we can start off with the law of sines, you need to understand a couple of conventions. The fact that uppercase letters are used for angles, lowercase letters are used for sides, and that the same letter will be across from each other, will be labeled across from each other. So lowercase a or side A will always be across from angle A. So the law of sines can be written in either one of these ways. I think most often in class we've seen it like this so far when you did the activity, but it could also work if you flip it upside down. Just kind of a matter of preference there. So we use the law of sines in two cases. Both of these cases are for non-right triangles. That's important for us to remember. So if it's a right triangle, go back and use the sine, cosine, and tangent with the ratios and the trig table and all that like we're used to. This is for the case when we have no right angles. In both situations here, we need to have 3 pieces of information and 1 unknown, and the unknown should be across from something we already know. So we could have 2 sides, or you could be given 2 sides and an opposite angle. So we have, here's 1 side, 2 sides, and an angle, and then we're looking for the angle across. Or we could be given 2 angles, 1 side, and be looking for a side across from an angle. So actually, if you look, I know that we always talked about how SSA isn't a good test for triangle congruence, but we could still name this triangle side-side angle. Side-side angle. And this triangle over here is angle, angle, side. Angle, angle, side. You don't have to remember that, it's just a little shorthand. So let's look at this first example here. We're given 2 angles and 1 opposite side, and we're going to solve for the opposite side. We're going to solve for this side marked X here. So, first off, I'm going to label my triangle. You don't need to do this, but it's helpful for when you're first starting and learning. So I'm labeling everything across from the same letters, capital letters for angles. And then I'm going to set, alright, so I know that we have the sine of A, and I'm going to use the sine of C, and side A is 11. Oh, wait, hold on. Before I fill it in, let me just keep setting it up. So then I can start filling in some numbers. Sine of 29 over 11 equals the sine of 118 over X. So then I'm going to cross multiply, and I'm going to leave everything the way it is right now and just solve it all in my calculator later. And I'm going to divide both sides by the sine of 29. So this is what I'm going to put into my calculator right here. I'm going to do 11 times the sine of 118 divided by the sine of 29. And we get X equals 20.0, or just 20. Example 2, we're going to solve for an angle this time. So I'm going to label everything, doesn't really matter. So in this case, I'm going to be using angles A and B, so let's set those up. Sine A, sine B, over A, over B. Fill in the values. This time we're going to put up, it's going to be the sine of x over 16 equals the sine of 115 over 49. Now, just a little comment, you might have been confused before because we haven't ever dealt with angles over 90. It's possible, and it involves actually circles instead of triangles to explain why it's possible, but your calculator can handle this. This is another reason why trig tables become less useful. We don't have this information on our trig table. So anyway, I'm going to keep solving this, cross multiply. Divide both sides by 49. And so I'm going to continue up over here. The sine of x is equal to 16 times the sine of 115 all over 49. So I'm going to solve for the side on the left here. 16 times the sine of 115 divided by 49. And I get the sine of x is equal to 0.2959. And I can finish this up on my calculator because I need to take the inverse sine of both sides. So on your calculator, you're going to use the second function to get the inverse, which you can tell it has that -1. Or you can look it up on your trig table if you still want to do that. And we get an answer of 17.2. I'm going to give you a second to try this one on your own. You're solving for an angle here, so you'll have to use the inverse, don't forget. Or look up on the trig table. So press pause when you solve it. I'm going to go to my next slide and I'll show you the solution. So the answer here, we're going to set it up. So there's my setup, then I'm going to fill in the values. I'm going to cross multiply and divide to get sine of c or sine of x by itself. Make sure you divide both sides by 55. Some people still divide by the wrong thing at this step. So at this point I have 20 sine of 110 over 55 is equal to the sine of c. I'm going to solve for the left-hand side and then take the inverse. So once I take the inverse of both sides, I get approximately an angle of 20 degrees for C. So try this one on your own. I'll be checking the answers tomorrow when you turn in your notes. Don't forget to summarize in addition to trying this example. In this example, you are solving for a side this time. So no inverses, just using your calculator you can solve for this. Circle your answer and I'll check it. And like I said before, don't forget to summarize. Make sure you are being thorough with your notes, and if you have any questions, don't forget to ask them and double check when you get to class tomorrow.